All right, so this problem here looks alternating, right? I got the negative 1 to the n plus 1. I got n squared and n plus 1. Let's just plug in some values here. If I plug in 1, I get positive 1. I get 1 squared over 2 squared. If I plug in 2, this is going to be negative 1, so I'll just put a minus there. This is 2 squared over 3 squared. Plug in 2, plug in 3. I get plus 3 squared over 4 squared. Minus 4 squared over 5 squared, dot, 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 dot. Right? So, feels like it's an alternating series situation. So let's now check to make sure what happens as n goes to infinity. So, the limit as n goes to infinity of n squared over n plus 1 squared. I'm going to multiply top by 1 over n squared and the denominator by 1 over n squared. When I slide that inside, it just becomes 1 over n. The limit as n goes to infinity of 1 over 1 plus 1 over n quantity squared, that's just equal to 1. We're done. Alternating series is out. Who cares that it goes back and forth? This diverges by the nth term test. Diverges by nth. And we're done. We don't need to do anything else. If a series doesn't go to 0, we can't use alternating series test. We just go back to the first test that we learned, which is divergence test or nth term test.